So I'm Phil Burr. So I'm responsible for developing commercial programs to make it easy to access ARM technology, and part of my role is to seek and listen to feedback from customers, and to make sure that we're providing the best experience for our customers. So I'm going to talk today about ARM Flexible Access for Startups. So this is a new initiative from ARM. It's focused on getting ARM IP and technology directly into the hands of early stage silicon startups. And in the past, I worked in the startup, so I've got direct experience of some of the challenges that startups go through, and some of the fun and the roller coaster ride that entails. So before I talk about flexible access startups, I thought I should just give a small introduction to ARM. And hopefully most of you know about this, but ARM's primary business is the development of intellectual property, or IP, that's used in silicon chips. And what happens is that our customers, or our partners as we prefer to call them, combine the ARM IP with their own IP to create their own chips. And ARM IP is very extensive, so I think we're most known for our CPUs, our processors, but we also have graphics IP, we have image signal processors, we have AI and machine learning technology, we have all of the glue and the systems that you use to put all that together. We do a lot of work on security IP and security software to make sure that people can use that technology, and we provide a lot of software as well. And then we have something called physical IP, which is the thing that companies use to map that logical representation to actual silicon.
Phil, you might need to do the present now again.
I lost that. Okay.
There you go. Thank you.
Okay. Good. Hopefully that carries on working. So we just go through. So a very, very brief history of ARM. So some of you may know that it was started back in 1990. It started off as a joint venture between Acorn Computers and Apple. So ARM had designed a CPU for a home computer, and that business went away, and Acorn was left with a CPU design. That got licensed for use in the Apple Newton, and then we went on to develop technology in CPUs for mobile phones, who were designed into the first mobile phones and into the first smartphones, but today actually used across all devices, across many, many different sectors, from automotive through to smart TVs, wearables, huge amount in IoT, in infrastructure and so on. So incredible market. Our partners have shipped an incredible number of devices. So 166 billion devices have been shipped with ARM in them up to December last year. So a huge number of devices. If you think about the number of people on the planet, that's a fairly big multiple of that. And so I think it's a good explanation is that most people have a fair few number of ARM devices with them or near them at any one moment in time, and so that number continues to increase. And we're at the heart of the major technology shifts. So AI or intelligence in every device, whether that's IoT, whether it's smart connected things, and so on. A lot in autonomous machines, in AR devices, whether that's mobile or consumer, and then in cloud and hyperscale compute. And underpinning all of that is an incredible amount of work that we do in security and privacy. And that's one, it's really important for ARM that our devices our technology is used in a secure way, that it enables privacy, and it allows our partners to create secure devices. And that's an ongoing exercise for us, and we put an awful lot into that to make sure that it's as easy as possible to make those. And I'm sure that in your IoT meetups, you've had, I'm guessing, quite a lot of sessions on security, because it is so important for IoT. Once you start connecting devices, then security becomes really important. So that was a small run through what it was ARM, but let's get into the meat of the presentation and to talk about ARM Flexible Access for Startups. So talk about what it is, why we've done this, and when's it available. And so what is it? Well, it's no-cost access to the world's most widely used chip design IP. So I've just talked about how ARM is used in so many different devices. And what we wanted to do is to make it as simple and easy as possible for silicon startups to use this technology. We want to make it as easy as possible for startups to be able to design and then tape out prototypes, and to do that without paying ARM any fees. And the reason for that is that we want startups to be able to conserve their cash and to really move on to the stage of their development quickly, and by not having to spend money on technology from ARM, then you can spend more money on recruiting people and speeding time to market. And the reason we're doing this is that actually we do see an incredible number of silicon startups entering the market. We had a program which I'll talk about called Flexible Access, and that's already been successful, helping startups get access to technology. And some of the startups said to us that flexible access was fantastic, but wouldn't it be really good if they could get get access to flexible access as early as possible in their cycle? And we thought, well, actually, why not? And why don't we just make it as easy as possible and lower those barriers? And so that's why we've done this. And we know that early stage in the startup is so critical and challenging, and we wanted to make it as easy as possible for startups to do that. So when's it available? Well, it's available now. We've already signed up a whole bunch of startups into the program, and for people to find out more, they can simply register on arm.com, and we'll just get back to the startups, find out a little bit more about them, and get them onto the program. So I mentioned that Flexible Access for Startups is built on a successful program already called ARM Flexible Access. And so it's worth just talking a little bit about ARM Flexible Access. So ARM Flexible Access is a program that we launched in July last year. We'd already signed 40 customers up to it. That may not sound that many, but in the silicon industry, that's pretty impressive. There are a limited number of customers who design silicon. It's still relatively expensive to do, and so it's the number of people who actually design silicon is within hundreds, and so to sign 40 up to this is really good. So what it does is really opens up and makes it easier to design and innovate in the silicon space. So we provide access to a very wide range of ARM technology, and normally we would charge an access fee for that, but that is waived for startups. And that access fee covers design rights, tools, and support. And for startups, we're removing that fee so that startups continue to get design to that technology, using that technology, get access to the tools, and we continue to support. And allows companies to experiment and design with any or all of the ARM IP in this package at any time. And what this does is lowers the barrier to entry. So companies can have the freedom to design and experiment, but only pay for IP at tape out. For the startup program, as long as startups continue to qualify as startups, then they don't pay for that IP in prototypes. But by removing the need to pay any license fees up front, then it means that companies can pause, they can change, and they can stop projects without any payment. And we've really simplified our business terms to make it much easier for companies. So this slide shows our traditional licensing model. So traditionally, a customer would select the IP, pay a license fee, develop their chip, tape out, and then manufacture. And then there's a small per unit royalty that they pay. With flexible access, we move that product license fee to much later in the development life cycle. So it means that, as I mentioned, that customers can access the technology, they can design, evaluate, experiment, and only at the point of commercial tape out do they pay a license fee, and then after that it continues as before. So those are the key differences between our traditional licensing and flexible access. So I mentioned that there was a large amount of technology that we're providing, and actually it's an incredible amount of technology. I think it's 16 of some of our most widely licensed technology, and these are used in an incredible number of devices. So for those that are familiar with ARM technology, then something like Cortex-A53, it's a very high-end processor capable of running Linux. It's used in many applications, from things like single-board computers to smart cameras, smart edge, high-end smart edge devices, and so on. And then all the way down to a tiny Cortex-M0. This is ARM's smallest CPU. It's used in many different devices. It runs a real-time operating system, or bare metal, so no operating system at all. And then everything in between. So we have, and if you look at the processors that we have there, then they represent 75% of the ARM Cortex licenses that we've done over the last 2 years. So an incredible amount of the number of licenses that ARM has done. So this is not just a small amount of our technology, it's a huge amount. But it also covers a huge amount of multimedia processing, so GPUs, ISPs, interconnect, so the thing that you use to connect all those CPUs together. Lots of that glue technology that's needed around processors. For people who are creating products that are used in safety applications, we have technology that help in that, that help customers get safety certification. We have debug and trace, the physical IP, and we have design kits that make it easy for people to create their systems. And we continue to add products to the package. So we've added things like safety packages earlier this year. We've added ISPs earlier this year as well. And then that's all built on tools, the training and support that I mentioned. And just to give a bit of a flavour what you can do with this technology, so at one end of the spectrum, you can create a complex device. So this is two clusters of quad core Cortex A53. So 8 CPUs on the same device, a graphics processing unit, all of the glue logic for that. Cryptocell is security IP technology that does the security algorithms and secure storage and so on. And these could be used in things like drones, in industrial control, in IP cameras, in smart edge devices. So it could be using machine learning. So we have technology, software that makes it much easier to implement machine learning on ARM technology. And in fact, most of today's machine learning at the edge is already done on ARM using the software that we provide. And that's providing some of the advanced security features that we have. And then at the other end of the spectrum, we have the Cortex M33. This is a small real-time processor. It could be used in a small IoT devices. IoT device, it could be for a sensor or a medical device or a smart lock. This implements our trust zone security capability that separates a small amount of secure software from the main body of the software. That means much easier to implement security on the device, and that works together with our Cryptocell, smaller Cryptocell product, and which does security algorithms and secure storages again, but optimized for those smaller devices. And this configuration uses our Corestone system, so it makes it easier to plug all this together. It's a verified system that our customers can then build around to make their own device. And this is designed for real energy efficiency, so it could be a battery power device. So that was flexible access. Flexible access for startups. We've got rid of those access fees, so it doesn't cost anything to access the technology. You can design with no cost. You can experiment, and you can prototype and create and manufacture prototype designs without paying out ARM any money. And this is targeted at startups who have less than $5 million in funding. So really there to help startups get started in their early phases, and to attract funding, and to prove technology and ideas, and to pivot, and experiment in those early phases. And this is giving access to that technology that powers those 160 billion devices. And when you look at the technology and the areas where we see silicon startups innovating, it is quite a wide range. And we sponsored a report from Semico Research, who also looked into the areas that startups are innovating, confirming, as it as fortune would have it, the number of startups that we see. Then there are 3 key areas. So a lot of companies looking at future automotive, from across the spectrum there. So it could be more smart driving, but it could just be improving the technology that's in vehicles. So so it could be more autonomous driving, or it could actually be some more mundane technology that's in the car. Huge amount of devices in Internet of Things, and the real aim there, I think, is optimizing power consumption, and often that could be machine learning based, or it could be by integrating analog technology with a CPU to get a really low power, optimized, low cost device. And then we see lots of applications that AI at the edge, and that's not surprising. There's lots of innovation that's going on there. And it was interesting to look at some of the funding. So the report showed that there's been a 10 times increase in funding between 2016 and 2019, helping showing that this is a really healthy number of opportunities for startups backed by VCs. And if you look at the amount of funding over the last 5 years, and that's excluding China, is 1.3 billion in funding, and excluding some really big amounts of funding from that. So that shows a distribution from a very wide set of customers. Set of startups. So I think if you look at the life cycle of a startup, then actually from my own experience of being in a startup, and actually talking to many of the startups that we work with already, you can look at two main phases. So that first phase is all about building investor confidence. It's about trying to convince investors that there's a really good idea, that there's the team there is able and to deliver on that. It's all about innovating and testing those ideas, and then the second phase is then really shifting to more about building customer confidence. So still managing investors and still continuing to make sure that investors believe in the team and so on, but it's about getting feedback from customers on product ideas, convincing them again that this is the right product, and again the team is able to deliver on that. But I think throughout all of those phases, it's about minimizing risk and reducing time to market. And this is where we believe there's ARM can offer an incredible amount there. So how the technology has been proven in many devices, thousands, billions of devices, and across thousands of designs, and really about minimizing the burn rate of cash, so that startups can get to market as quickly as possible and into revenue. So how do we minimize that burn rate? Well, you'll be pleased to know I'm not going to present all of the detail on this slide, but yeah, I think what we try to do on this slide is to break down the phases in a chip development and look at how ARM helps in that. So if you look at, for example, the stage of experimentation, then being able to rapidly prototype, we provide models of our technology, so that as a startup you can experiment with your design, work out which of the CPUs and other technology is the right one for you. And by having models, it's much easier to do that. You can run software in those models, and you can plug look at performance within those models, and it's much simpler. You can then startups can then do system design, and we provide lots of ways to help with that. So we provide reference designs, We have technology that just plugs together and has been designed together. We have standardized interfaces and so on. I wanted to just highlight verification as a key difference for ARM. So we have a huge amount of technology that we have developed over decades that make sure that ARM technology works. And we also have technology that helps make sure that ARM technology works in customer designs as well. So we provide that to customers. And this makes an incredible amount of difference to a startup. And we talk to some of our customers, and they can tell us that it can save at least 5 man-years of effort in that design. And for a startup, that's an incredible difference. And then another area to highlight is around that physical design. So we work really closely with the providers of those design tools, and together we make sure that ARM technology just works in those design tools, that works across all of the major foundries that create those chips. And again, that makes a huge difference. And again, that can save between 3 and 5 man-years of effort. And then I think the other area to highlight is around software. So the fact that ARM CPUs and the technology are used in so many different applications, and that there's an incredible amount of software that's available that just works out of the box on ARM, that makes a huge difference when you're creating your devices. And that could be, for example, as a startup today, you could be thinking about creating a product that uses an off-the-shelf device, and then some time later creating a custom device. And it's that software that works across those different devices that makes a big difference. And you can take that software and then port it onto your own device. And so when we looked at the CPU design costs, we could identify that the development costs on ARM were 52% lower. And that makes a huge difference for startups. So the other area of saving that's particularly relevant from ARM is the fact that a large silicon company will have hundreds, if not thousands, of software and hardware engineers within their teams. As a startup, then you don't have access to all of those. And so what the ARM ecosystem has is hundreds and if not thousands of engineers that are very familiar with ARM, that a startup can pull in to help with their design. So that could be a team to help in the system design. It could be a company that is brought in to help with verification, or it could be software engineers that are helping the design. But it just, again, helps in the speed up and getting access to that huge talent that's available and supplementing a startup's own design. And I just wanted to highlight on this slide a couple of companies that we're startups that we have already helped get started. One company is Atmosic, based in the US. They are already using flexible access, and they managed to get 28 million of funding just in December 2019. And they're designing, experimenting with flexible access. Another company is Halo, based in Israel. They're developing an AI product. They've worked with us since 2016. Started off with a different program that we had called Design Start, and they won $60 million of funding in March 2020. And we've had a whole number of companies or startups that have started with ARM and have since gone on to be really big, successful companies in their own rights, or to be acquired by large silicon vendors. And what we've recently done is announced a strategic partnership with Silicon Catalyst. They're an incubator who are entirely focused on silicon startups. And what this partnership does is allows startups to get access to IP, to tools, and to help and mentoring in that early stage of the development. Again, this is all about helping startups get off the ground and into their development. So just to summarize again what flexible access offers. So it's everything that a startup needs for their SoC. So it's not just those vast swathe of technology and of IP. It's also things like tools and models that I mentioned that help people use that technology, help them decide what technology to use to simulate, to do performance, and to develop software. It's that wide range of technology across CPUs to physical IP, but it's also that support and training to help our customers and startups design with the confidence and that they need. And we also provide lots of online training as well to help people use that technology. And I mentioned that all of this was built on a foundation of security and safety. And again, that's really important for us, particularly in security and IoT. And we do an awful lot to make sure that it's as easy as possible to develop security on our technology. So we believe that as a startup, then startups need to be agile. They need to be able to experiment, try ideas, and pivot when needed in that early phase. And by giving access to that really broad set of technology, then we allow startups to do that. We make sure that startups can conserve cash in this phase of their growth, and absolutely minimize spending so that you spend money with ARM, spend money on engineers, and to grow faster. And by providing technology that just works, allows startups to focus on the key differentiating parts of their product and the magic sauce, and that's really important to make sure that you get to market as quickly as possible by just focusing on the differentiating parts. And it's really that focus on that provides that clear path to success. So it's about using technology that just does work, that is proven, and gets to market as quickly as possible, minimizing burn rate. And we believe that ARM flexible access for startups enables that. So that's all I wanted to cover today. I wanted to leave plenty of time for questions. If you wanted to know more about it apart from the questions, then there's a link there, but actually much easier just to search for flexible access for startups. And on that, I'm very happy to take any questions.
Thank you, Phil. That was great. Again, reminder, if you have questions, is to post it in the chat, and we'll get to the question. I actually have a question around actually getting the physical product built. So a lot of the tools you're providing help with design, essentially get it to a point where you now need to build it. I assume you have an ecosystem that actually helps you get to the next stage, is building the physical chip.
Yes, that's correct. So we have a very extensive ecosystem, and that spans quite a long way. So that ecosystem could be people who provide design tools. So EDA vendors, electronic design automation vendors, who have design tools. And I mentioned in the presentation that we make sure that our technology works on those tools, that if you're building a chip that you use. We have very strong partnerships with silicon foundries, so the places where chips are built, and most of those companies have programs that make it much lower cost to get a tape out, and particularly on prototyping. So these initial prototypes are done on shared wafers, so called multi-project wafers. So you share that wafer with many other companies who are in that early phase of the chip design, and it's possible to either to utilize a program that some of those silicon foundries have, to get no cost tape out, or to really reduce the cost, and it could cost as little as about $16,000 to get test chips on more mature nodes, and that for some products is actually ideal, particularly on analog mixed signal products. And then, of course, the other areas of ecosystem around software, so either software tools or software itself, and that software could be commercial tools, but there's an awful lot of open source tools as well. Commercial software, or an awful lot of open source software as well that just works on ARM, and many embedded and IoT software is actually designed and developed on ARM, which makes it much easier, clearly, to get started on this.
Mm-hmm. Cool. And so where are the foundries that you work with in terms of location? Here, Europe?
Well, many of the foundries are based in Asia, many in Taiwan, but actually a lot of them have partners across many countries, so and many in the US as well. So not surprisingly, and it's often those companies that are a good first port of call as a startup, because what they do is they integrate all of the startup and other designs onto that silicon for a multi-project wafer tape out, and that's what makes it much lower cost to create those devices.
Cool. Okay, looks like we have a question from Brady. Brady, do you want to hop on? Brady?
Yep, sorry, I had to scramble.
No worries.
Curious if you've ever worked with incubators or co-working spaces before, and if you'd be interested in doing so. This just sounds like this could be super useful for the types of companies that I'm hoping to get in here.
Yes, so we have, yes, in a number of areas, actually. So we have worked with incubators on the silicon side of things before, and we're still doing that. And we probably have more partnerships, I'd say, across the world in people who are designing with ARM chips. And we have an initiative within ARM itself called ARM Development Program, where we work with people who are are developing spaces or doing incubation for people who are designing with ARM chips as well, so chips that our partners develop. So it'd be really good to just to get in touch directly, and we can we'll talk further on that. It's something that's really important to us.
How does the relationship with Silicon Catalyst? I guess I hadn't heard of them. Where are they based? And is it just a straight up partnership for you guys?
Yeah, so it is a partnership. Silicon Catalyst are they're headquartered in the Valley. They have an office in Israel, which is there's quite a big startup scene in Israel as well, and they have a partner in China. And the way it works is that they partner with a number of companies, ARM included, and focused on silicon companies. So for example, they are partnering with people who provide the design tools. They do partner with people who companies who are working with fabs, and so many of companies provide kind of benefits to those startups and also mentoring to the startups. So it's that combination of all those different companies, including ARM, and the mentorship that Silicon Catalyst provide that then makes it the help a startup get going, and they can help attract VC funding as well by providing that incubation and that help. And so many of the companies that are in the Silicon Catalyst partnership are ARM ecosystem partners already. So we're already working with them very closely, so it's a great fit for us.
Yeah, it's an easy partnership, as it were.
Absolutely, yes, yeah.
All right. Yeah. Any other questions? No. All right. This is fantastic. Thank you, Phil.
No, thank you. So I hope that was a good way. A good overview of how to get started designing your own silicon and how it can help. And if you would like to know more, then visit the ARM website or just please reach out.
Perfect. Yeah, and we'll get the word out as well to the rest of our community locally here as well.
Wonderful.
About the program. But thank you very much, and have a great evening. And thank you.
Yeah, well. Yes, thank you. Have a good day. Thanks.
Yeah.
Bye-bye.
you